In this video, I want to introduce a very exciting company, which I hinted at in my last video when I was going through the list of companies that I IPO'd last month. The company's name is called Nano-X Imaging, ticker symbol NNOX. Nano-X is based off in Israel, which is known for breeding a lot of successful startups. And the problem that Nano-X hopes to solve is the issue of costly and inaccessibility of medical device imaging, specifically X-rays. X-rays have been around for over a century, and the core technology, surprisingly, has not evolved all that much since its beginning in 1895, even though these X-ray imaging technology is crucial in early detection of life-threatening diseases like cancer. So there are two main selling points of Nanox's products. The first is the lower price point of the so-called Nanox Arc, compared to traditional X-ray machines. And the second is the increased speed of diagnostics through the use of cloud and AI. First, let's talk about the price. A few of the reasons why traditional X-ray machines are so costly is because they require a complex rotating mechanism and a cooling system. Let me play a short clip from Nano-X about the problems of traditional X-ray machines.
To understand the Nanox breakthrough, we must first understand how X-ray works. X-rays are produced in a large vacuum tube using technology that hasn't changed since it was first discovered over 100 years ago. It relies on heating a metal filament to 2,000 degrees Celsius. The heat then causes the filament to emit electrons that are accelerated toward an anode across from it, producing the X-rays upon collision. This process heats the anode to such a high degree that it must rotate to distribute the heat across its surface to prevent its meltdown. Nanox's novel X-ray source technology eliminates the need for extreme heat in this process. Instead of heating just one filament to produce electrons, Nanox has developed a silicon chip that distributes the task across 100 million nanocones, digitally controlled. Electrons pulsating from each cone hit a different spot on the anode, which also keeps the anode cool without the need to rotate it. The exceptionally small size and low cost of the Nanox X-ray source enables us to construct medical imaging systems using multiple stationary tubes and no moving or rotating parts.
So every X-ray machine has X-ray tubes that convert electricity into X-rays by accelerating electrons so fast that the heat generated during the process can reach up to 2,000 degrees Celsius. And there aren't that many materials that can withstand such temperatures, so it's important for these machines to have a cooling system. And Nanox's advantage over these traditional machines is that it gets rid of the two costly methods of producing X-rays. One, the expensive mechanisms required to accelerate the electrons, and two, the cooling systems to keep the machine from basically melting down. And because these machines require such complex machinery, a new high-end CT scanner sells for more than $1.3 million and up to $2.1 million, with additional costs ranging from $15,000 to $100,000 for the software, and of course there are costs for maintenance for the machinery. In comparison, Nanox estimates that it will cost them $8,000 to $12,000 to build one of their machines. This estimate is of course subject to change depending on how many machines they plan to build, so we need to keep a mental note of that. But still, replacing a machine that costs over $1 million for one that costs 99% less than the old machines is insane, if it's possible. Now that we understand the potential of this company, let's discuss the technology. The fundamental technology of Nanox's system is based off a display technology called the field emission display, also called FED technology. This FED technology was originally owned and developed by Sony for television screens and monitors. And so Nanox's X-ray technology uses a digital chip that is designed so that the X-ray source can be turned off and on instantaneously. So, if a patient is undergoing a surgery that requires constant monitoring, then the doctor can limit X-ray exposure to both the patient and the hospital staff by turning on the machine only when needed. And this, Nanox claims, will significantly reduce the amount of X-ray exposure to the patient. But the Nanox Arc, which provides the imaging solution, is not the only product that is being developed by this company. As I mentioned earlier, Nanox is also developing an AI and cloud system that they call Nanox Cloud, which is software that will deliver medical screening as a service. So another edge that Nanox will have over the current competition, if all goes right, is that traditional machines require multiple licenses of computer analytics and software to interpret the images that are captured. And Nanox Cloud will include this analytical side of the X-ray business and provide an end-to-end medical imaging service, from diagnostics to billing. And so, the Nanox Cloud addresses one of the major issues with traditional X-rays, which is the long wait times after being scanned, with wait times for a CT scan in Ireland and the UK taking as long as 12 months. And to talk about the business model of Nanox, there are three. The first is the subscription model, where Nanox will charge their customers little or no upfront fee for the machinery, so the hospitals will get the Nanox machines basically for free. And instead, the customers will pay for each scan, and they expect these costs will be less than $300. To give you a bit of perspective, in the US, the average cost of a CT scan is about $3,000. And the second is the sales model, where they will sell the devices for a one-time charge for certain countries with specific regulatory requirements, like in China. And the last is the licensing model, where Nanox will basically allow manufacturers to create specific systems of medical imaging devices to upgrade their X-ray machines. And Nanox will get a one-time licensing fee as well as royalty payments for each system that is sold. According to their registration document, Nanox will use the licensing model in the beginning, and as the demand for their product and services go up, they will transition to the subscription model. And I think this is great because the subscription model will allow Nanox to continue to generate revenues basically forever until another company comes in and creates a better alternative. And apparently some of the bigger companies are into this new technology. For example, SK Telecom, which is one of the largest telecommunications company in South Korea, invested $5 million in 2019 and an additional $20 million in June of 2020. And a whole bunch of other companies have reportedly agreed on a deal or invested in Nano-X, like USARAD, which is a radiology company that provides radiology services across all 50 states in the United States. In addition, they received an investment from Foxconn, which is a major global electronics manufacturer with very big name customers like Apple. But since the Nano-X devices are not FDA approved and are still being developed, we should all keep in mind that things can go south for this company real fast. And recently, there was a report released from Citron Research that called Nano-X a scam, which caused the share price of Nano-X to fall more than 20% in one day. And so this type of volatility is something that you should expect for a company that is valued at a few $1 billion with basically no revenues. So overall, I would recommend waiting until Nano-X gains FDA approval, or even just waiting until Nano-X proves its business model as a profitable one before investing. That's going to do it for this video. Let me know down in the comments what your thoughts are about the company, and I will see you guys in the next one.